Hi guys, we meet again. So in this video, we are going to cover on the center of gravity, center of mass, center of area, centroid basically, and the application of centroid to composite body. Okay, so stay tuned. Okay, the centroid of an object is like a point of balance of that particular object. So deciding the exact location of the centroid or the center of gravity or the center of mass or the center of area, depending on the situation, is very important in many engineering applications to provide a sense of stability during the engineering operation. Okay, for example, the design of a car requires the center of gravity to be as low as possible for stability during driving maneuvering. Okay, another example, sometimes during construction, it requires the lifting of a heavy concrete wall to a specific destination. So the knowledge on the exact centroid is very important to ensure that the cables are attached appropriately so that the wall does not tilt or wobble or become imbalanced during the transferring operation. So in this chapter, we are interested to define the location of the centroid, especially when it involves irregular objects with irregular features. Okay? Okay, now let's consider a body with an irregular profile. Okay, this body is made up of many small particles with different size. Okay, you imagine like a body is being built up by a Lego. If you assemble the Lego on top of one another, it will create many randomized shape. Okay, so that Lego block is the particle that we're talking about. So each particle will have its own weight, and because its weight is relatively small compared to the total weight of the body, then usually we call the weight of the particle as differential weight, okay, or dW. The weight of each particle, which is the dW, will act at the centroid of each particle. Okay, the total summation of the differential weight of each particle would be the total weight of the body. So this total weight will pass through a single point of the centroid of the body. Usually we call it the center of gravity. Okay, now if we plot the particle against the XYZ axis, then the centroid of the particle, the single particle, or the coordinate of the center of the particle is labeled as X curve and Y curve. Okay, there's a curvy line on top of it. So that is to define the center or the centroid of a single small particle. On the other hand, the total weight of the entire body, which act at the centroid of the body, or we label it as the center of gravity or point G, the coordinate is defined as X bar, Y bar, and also Z bar. Okay, so basically we can find the center of gravity of the weight for the entire body by using the integration formula. Okay, so basically you need to multiply the center point of all particles, which is the X curve, Y curve, and also Z curve, with the weight of the particle, dW, differential weight, and you have to divide it with the weight of the particle again to get the overall center point of the entire body, to get the X bar. So normally we would use the integration function in formula like this, because integration is like a summation of a big thing, summation of an irregular profile. So as the body is made up of many particles, so that is why the integration function is very useful in this particular application. Concept of center of mass is very similar to the concept of center of gravity or center of weight. So the only thing that changed here is that you are now measuring against the differential mass of each particle. So in the bigger picture, you are measuring the overall mass of the entire body, which act through a single point. This time it is called the center of mass, or we label it as CM. So the formula to get the center of mass, usually we use the same integration function. The only difference now is that we are measuring against dia punya differential mass, the dm value here. Okay, as the name goes, when measuring for the center of volume, we are now measuring against the volume, the differential volume of each single particle. So therefore, the entire volume, the total volume of the body will act through a single point, which we call as the centroid of the volume, or we label it as C. So the formulation is very similar with the center of gravity and center of mass, just that the only difference now is that we are measuring against the differential volume, this bling 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 arrow line over here. Accordingly, center of area is the centroid of the entire area. So let's say, okay, as you can see in this particular slide, there is a boundary warna biru yang curvy line tu is bounded by the x and y axis. Okay, so now we wanted to determine the location of the center of area of that particular boundary. So there are two ways for you to calculate the position of the center of area. Okay, one of the way is by using the vertical strip. Okay, in using vertical strip, you have to draw like an imaginary vertical strip lah along the x and y axis like this. Okay, we call it vertical strip sebab dia memanjang macam tu. Okay, this strip will represent the particle of that particular boundary. Okay, so therefore the length of this particle along the x-axis would be dx, differential x value. Okay, the concept is very similar with the previous slide, okay, because it is a particle, so anything yang macam relatively a small value tu kita letak differential amount depan dia, d depan dia. Okay, so now let's say the coordinate on top of this strip is x and y. So x would passes through a middle point of the strip, so the x position is over here, and coordinate along the y direction, we call it y. Okay, now, the centroid of this vertical strip would be exactly in the middle of the rectangular shape over here. Okay, so therefore, if we measure the distance along the x-axis, so we call it x curve because it represents the coordinate of the particle. So the x curve is equivalent to x value. Okay, and accordingly, the y curve, okay, is equivalent to y over 2. Kenapa y over 2? Sebab usually the centroid of a rectangular area is exactly in the middle of the width and the height of the area. Okay. Okay, we can also find the center of area by using a horizontal strip. Okay, the concept is still the same. You need to draw the strip horizontally this time around. Okay, so the height of this particular strip would be differential y, dy. Okay, and if the coordinate of this particular point is x, y, which passes through the middle point along the y-axis, so we can say the distance from this origin along the y-axis is y, and the distance to the top of the particle from the origin would be x. Okay, so if we want to define the centroid of this particle, then along the x-axis, the x curve would be equivalent to x over 2, half of it, okay, only half of the strip. Whereas the y curve, the coordinate of the particle along the y-axis, y curve is equivalent to y. Okay, now the formula to define the centroid of that entire area, that blue boundary over there, is by using the integration function as well. Okay, so the x bar or the x coordinate of the centroid would be integration of the x curve, which is the x coordinate of the particle or the strip, multiplied with the dA, which the area, differential area of the particle or the strip, divided with the integration of dA. Okay, the same formula applies when you want to calculate the centroid along the y-axis. Okay, you can refer to this table for the centroid of area for simple and basic shapes like the triangle or the rectangle or the semicircle. Okay, let's look at this example. In this example, you are required to locate the center of area for the blue boundary box. Okay, so before I proceed with the analysis, let me just redraw the diagram again so that I don't get confused with all the many measurements given in the original diagram. Okay, done. So this curve is defined by the equation of y equivalent to x over 2. Okay, and the boundary of this area is bounded from 0 to 1 along the x-axis, and also another 0 to 1 along the y-axis. Okay, now let us use a vertical strip to define the centroid of this particular area. Okay, so this is our strategy. First, we need to find the coordinate of the vertical strip, the x curve and also the y curve. And then we need to find what is the representation of the dA, the area of the vertical strip. And then we can solve and look for the coordinate of x bar and y bar, which is the centroid of the area, by using the integration formula. So for convenience of the data, I'm going to put all this in a table. Okay, the first row of this table consists of the x curve that we want, and then the second row would be the y curve, and then the third row would be the dA value. Okay, now looking back at our diagram, this point on the vertical strip would be the coordinate x and y. Okay, the centroid of this vertical strip would be at this point, exactly in the middle of the rectangular shape. Based on this diagram, the coordinate of the vertical strip along the x direction, or the x curve, is equivalent to x. Okay, so we just put that x thing into our table. Okay, so that's the value that we want. Okay, on the other hand, vertical strip measured along the y direction would be y over 2. So we put this y over 2 over here. Okay, how about dA? dA is actually the area of the vertical strip to represent the particle basically. If you recall, the height of this vertical strip is y, and the length of this vertical strip is dx. So therefore, the area of this vertical strip would be panjang kali lebar, ataupun you can also write it as y dx. Okay, now we have enough information to solve for the x bar and y bar. Okay, so recall the formula for x bar is equivalent to integration of x curve multiplied with dA divided with integration of dA. Okay, so now we are going to put all the information that we have placed in the table earlier. Okay, so the x curve is equivalent to x. Okay, so we'll just replace it with x, and then the dA is actually y dx, and divide with the integration of dA. Again, dA we replace with y dx. Okay, now recall that the y is already given to be x squared. It is given as the boundary of the curve. So we are going to replace the y with x squared over here, and this y also will be replaced with x squared over here. Okay, so all as the expression on the rightmost side is x, so we have to make sure our equation only contains x in it. Okay, so now as this is an integration, so along the dx direction, so we have to look what is the boundary along the x direction. In this case, the boundary is within point 0 to point 1. Okay, so we are going to write it like this. The range for the equation at the bottom side is also within the range of 0 to 1. Okay, let us multiply this particular part. So x multiplied with x squared, it will become x cubed dx, and the bottom part remain as it is. Okay, now when we want to use integration, recall balik kelas matematik dulu, it adds up to the variable. So therefore, if you integrate x cubed, it will become x 3 plus 1, which is x to the power of 4, divided with the new power, which is 4. Okay, and then you have to calculate it within the range of 0 to 1. Okay, at the bottom part of it, x squared, if you integrate x squared, it will become x cubed divided with the new power, which is 3. And then you have to calculate it for the range of 0 to 1. Okay, so the next step is, okay, first you have to apply the value of 1 into the x. So this will become 1 to the power of 4 divided with 4, tolak dengan minus with, okay, you have to substitute the x with the bottom value, which is 0. So it becomes 0 power of 4 divided with 4. Okay, so at the bottom of the fraction, again, accordingly, substitute 1 into the x, will become 1 power of 3 over 3 minus with 0 the power of 3 over 3. So, just sama je lah. Okay, so this equation, okay, on the upper side of the fraction, it becomes 0.25, and at the lower side of the fraction, it becomes 0.33. So, use your calculator, and you will get the value of x bar to be 0.75 meter. Okay, now let's find the centroid along the y direction pula. Okay, so the y bar is equivalent to the integration of y curve multiplied with the dA divided with integration of the dA. Okay, so now according to the table given, the y curve is equivalent to y over 2. So we just substitute that into our equation over here. Okay, and then the dA is equivalent to y dx. So we just put that again into our equation. Sama juga macam dekat bawah ni. Okay, now if I were to multiply y over 2 with y, it will become y squared over 2 dx, and then divided with the integration of y dx. Okay, so what else? Okay, already given the curve equation, y is equivalent to x squared. So if I were to substitute that expression in our equation, so this y squared become x squared power 2 lagi, and then divided with 2, and then multiplied with the dx, and divide it with the integration of x squared dx. Okay, why do I have to do all that? Because I have to make sure all the unknowns in this equation is the same, which is kalau dekat hujung tu dx, then the variable should be in x as well. Okay, so if I were to x squared kuasa 2, it will become x to the power of 4 divided with 2, and yang bawah ni kita just carry it over again. Okay, as we are integrating along the x direction, then we use the boundary of x, which is from 0 to 1. So this part will be 0 to 1. This one is also from 0 to 1 as well. Okay, now time for integration. So if you recall, integration tu we add up to the variable. So x4 over 2, it will become x to the power of 5 divided with 5. And then jangan lupa, 2 tu still remain as it is lah. Okay, and you have to calculate it in the range of 0 to 1. Okay, on the bottom side, the integration of x squared would become x cubed divided with 3, and it should be measured in the range of 0 to 1 as well. Okay, so you just substitute the value accordingly, just like the previous step, and you will get the y bar to be 0.3 meter. So from this analysis, we can conclude that the center of area, or C, for this boundary is equivalent to x bar and also y bar. Okay, oh saya tertinggal tulisan bar kat atas tu. By which the x bar is 0.75 meter and the y bar is 0.3 meter. So if I were to redraw the boundary, the shaded boundary over here, okay, the curve and also the range is from 0 to 1, and so in this one is also from 0 to 1. So the centroid would be 0.75 meter measured from the origin along the x direction, and along the y direction, if measured from the origin, the distance would be 0.3 meter like this. So this is the position of the center of the shaded area.